So we need to find the electrical power saved. So T sub L is going to equal 21 degrees Celsius. T sub H is going to equal 32 degrees Celsius. We're going to convert this to Kelvin. So we'll say 294 Kelvin. And here we'll say 305 Kelvin. We have Q sub L, Q sub, my apologies, Q sub L over T, and this will be the first power output of 4.8 kilowatt hours, or we can simply say not kilowatt hours, simply 4.8 kilowatts or 4,800 watts. Q sub L over T will simply, for sub 2, will simply be equal to 500 watts. So we should first find, we can find the electrical power saved by saying, okay, E, the efficiency, is equal to 1 minus T sub L over T sub H. We're going to assume that this works ideally, and we can say that this is going to be equal to the work divided by Q sub H. And we can further define this. This is going to be equal to work plus Q sub L, and work as the numerator. And we can solve for work and say work is going to be equal to Q sub L times T sub H divided by T sub L minus 1. And we can divide by time. So work divided by time is going to equal Q sub L divided by time. And then we'll say T sub H over T sub L minus 1. And we actually have these. So we can say work over time for 1 will equal 4,800 T sub H over T sub L minus 1. And then we can say that work over time, and actually it will be work over time sub 1. So it'll be outside the parentheses. And then sub 2, this is going to equal 500 watts. So now we're going to be using Q sub L divided by T sub 2. And this will be equal to 500. And again, T sub H over T sub L minus 1. And at this point, we find that the electrical power saved will be equal to savings. This is going to be equal to work over T1 minus work over T2. And this will be equal to 4,800 minus 500. And then this will be 305 divided by 294 minus 1. And we're getting that the total electrical power saved is going to be 161 watts. So this will be our electrical power saved. That is the end of the solution. Thank you for watching.